Now it will be telecasted. Yes, now it will come. Streaming. We'll wait. If they don't telecast, then ban చేసుకుంటాం. Right. They don't telecast, then ban చేసుకుంటాం. Mute చేద్దామా? Okay, welcome to the one more session. So I've been discussing about abstractions of precipitation. Yesterday we completed evaporation, right? So before we get into details, so Unacademy offering 23% discount on all subscriptions. So offer closes, it's a limited period offer. Offer closes very soon, so enroll. Unacademy is conducting all India level mock exam free of cost. You can enroll. So they're conducting different kinds of tests at reasonable price, and in that too they are giving you 10% discount. Make use of this. Okay, then let us start. So yesterday we completed evaporation, right? So two approaches are very, very important. One is water budget method. The other one is the pan measurement of evaporation. Pan measurement of evaporation is equal to, it is P plus or minus Z. Water budget equation. So evaporation we measure by using sigma inflow minus sigma outflow is equal to plus or minus delta S. So inflows are, it is P plus R, outflows are O plus E plus S is equal to plus or minus delta S. So using these equations you can work out. These two things you are familiar, more than sufficient related to evaporation. Then continuation our discussion with respect to abstractions of precipitation. Next one is evapotranspiration. Sorry, it is transpiration first, then we'll see evapotranspiration. So transpiration is the process by which water leaves the living plants. Evaporation is the process by which water leaves the water bodies. It changes its state and escape into atmosphere as a vapor. From water bodies like rivers, canal, lake, pond, reservoirs, so much water evaporate every year and accumulate as moisture in atmosphere. Exactly same way, through plants and trees also so much water evaporates every escape into atmosphere as a vapor. So that is also taken as a loss, catchment loss. Anything going away from catchment is treated as loss. Truly speaking, there is no loss, no gain. It is all perception. So being a surface water hydrologist, anything going away from ground surface, that is treated as a loss. Okay. So transpiration is the process by which water leaves the living plants through stomatal opening of the leaves of the plant. So it's very, transpiration is the process by which water leaves the living plants through stomatal openings. Stomata means micropores will be there to the leaves of the plant. Through that micropores, so much water get out of the plant. That is called transpiration. So this is something like this. So plants require water for their survival. They draw this water from the ground, right? And they store that water in the cell space. The cell space of the plant completely filled with water. Plants, we all know that they prepare their food material on their own through photosynthesis. During photosynthesis, what it requires? Water is required, carbon dioxide is required, sunlight is required, solar radiation is required. So photochemically they convert and prepare plant proteins and plant nutrients and survive. Okay. So but unfortunately all of the cell space inside the plant is filled with water, but there is no space left in the cell space to accommodate carbon dioxide. So where from it can get carbon dioxide? From atmosphere. So to accommodate that atmospheric carbon dioxide in the cell space of the plant, some of the water absorbed by the plant from the ground, so it expelled back from the plant. The water is expelled from the stomatal openings of the leaves of the plant, that straight away diffuse into atmosphere as a vapor. That loss is taken as transpiration. This is a leaf of a plant. This is a plant leaf. This leaf contains micropores. You can't see them. Small openings would be there. Through these openings, what happens? So water get out of the plant. H2O will get out of the plant. The space left by the water immediately filled by what? Carbon dioxide. To accommodate carbon dioxide, it vacates some water. The water which is vacated from the leaf of the plant, that escape into atmosphere as a vapor. So this is called transpiration. Leaves of the plants. Okay. So this, unlike evaporation, transpiration is confined only to daylight hours because it requires solar radiation also. Whenever that photosynthesis occurs, during that period only you can find transpiration. Night time you don't find solar radiation, therefore night time there is no photosynthesis happens in the plant life, therefore there is no transpiration occur during night time. So transpiration is confined only to daylight hours. It happens only during daytime. Transpiration is confined only to daylight hours. So you don't have any mathematical concept to measure transpiration loss because it's a very slow process. So much time it will take to eject water out of the plant. Okay. So therefore you can't wait that much time period, that too very small amount. So transpiration is measured by a device known as, only physically we can realize by using a device known as phytometer. Transpiration is measured by a device known as phytometer. Just this point you ought to remember. This phytometer consists of one container filled with soil. A container filled with soil. Okay. This completely filled with soil. We sow one or two plants inside the container. Sowing means what? Right? Plants we grow inside the container. This is a plant, suppose assume. This is a plant. These are leaves of the plants. Okay, assume. At particular stage of plant growth, what we do is, we add certain amount of water. So water added to container. This is weight of water added to container. Certain water is added to container. So that soil in the container absorb that water. So as soon as we add water, immediately what we do? We seal the container from the top. Container is completely closed from the top. It is sealed. Right? It is completely covered. So there is only one way of water that is added to the soil here. So that is get out of the container only by one way. What is that way? So plants has to absorb that water. This water has to go to plant cell space through roots of the plant. They get into cell space of the plant through stomatal opening. Water start escaping out of the plant. So this is how it is moved. The difference in weights will give the water that is transpired by the plants. So that's how we can work out. This setup is called phytometer. Okay, anyway, phytometer, that much idea is there, more than sufficient. Transpiration So to make comparison, which plant transfer more water, which plant transfer less water. So it all depends on what type of plants we grow, what type of plants are there. So depending upon that, so transpiration depends, because we are all human beings. Each person, the amount of water I consume is different. Some amount of water consumed by some other person is different. So all of us do not consume same amount of water. Same way, all of the plants, they don't consume same amount of water. Some draw more water, some draw less water. It all depends. Okay. So therefore, to make comparison among the plants, which plant transfer more water, which plant transfer less water, what we do is we work out transpiration ratio. What is that? Transpiration ratio. So transpiration ratio is the measure of means of comparison among the plants. So it is amount of water added to the amount of water consumed by the plant, or weight of water consumed by the plant during its full growth to weight of dry matter produced by the plant after wilting. Wilting means after death. Plants die. The plant's death of the plant is called wilting. So human beings die, plants wilt out. So the weight of water consumed by the plants during their full growth. When they are fully grown, at that time, what amount of water they consume. Full growth to weight of dry matter produced by the plant. After wilting. So this is a means of making comparison among the plants, which will transpire more water, which will transpire less water. That much idea is there, more than sufficient. So this is about transpiration. We don't have any mathematical approach, so you can't expect any numericals from transpiration. We don't have any approach. Then the next one is very important, which is called evapotranspiration. Transpiration, you got idea now, so automatically you can also get good idea regarding evapotranspiration if you are thorough with the transpiration. Evapotranspiration, whichever nation that practices agriculture intensively, that nation experiences more evapotranspiration loss. So India is agricultural based country. Therefore, so much water we apply to agricultural lands, so all of the water that applied to agricultural lands, they are not used by the crop. So most of the water, the crop transpire to the atmosphere as a vapor. So that loss is called evapotranspiration. So evapotranspiration is nothing but it is plant evaporation as well as land evaporation, immediate surroundings to the plant. Both of them together known as evapotranspiration. So evapotranspiration is sum of plant evaporation. What is plant evaporation? Technically, transpiration. Plant evaporation and land evaporation or ground evaporation in the immediate surroundings to the plant. So where do you find more amount of land evaporation, plant evaporation? In agricultural lands, in the immediate surroundings to the plants. Okay, it's known as evapotranspiration. So evapotranspiration is nothing but it is sum of, we denote it by ET. So evapotranspiration ET is equal to which is nothing but it is land evaporation plus plant evaporation. Plant evaporation plus land evaporation together known as evapotranspiration. So where do you find land evaporation, plant evaporation? Agricultural crops. So agricultural crop is there. So some cropland, some crop, rice crop or sugar cane, whatever it may be, some crop farmers are growing some crop here. So we apply so much water here. So all of the water applied to the crop, it is not used by the crop, so much water get out of the crop through stomatal openings of the leaves of the crop, and as well as some water evaporate from the immediate ground also. Ground evaporation plus plant evaporation together. This is a symbol for land. This is a land or ground, whatever it is. So together known as evapotranspiration. This is how it happens. Land evaporation plus plant evaporation is known as evapotranspiration. But this topic is important because India being a agricultural based country, so much water every year evapotranspirate from agricultural lands. Therefore, it's a major loss for us. So therefore, we need to consider. Let us see. So there are two types of evapotranspiration. That's where confusion lies. There are two types of evapotranspiration. One is called potential evapotranspiration. Potential evapotranspiration means what? It is shortcut, we write it as PET. Potential evapotranspiration. Second one is actual evapotranspiration. Which is called AET. So you suppose to know the difference between PET and AET. Truly speaking, to work out PET, we have got so many number of mathematical procedures, but we don't have any procedure to work out AET. Therefore, but AET is only we are interested in AET, actual evapotranspiration. So to work out this AET, what we try to do is we take the help of PET. Therefore, both of them are equally important. So let us see what is PET. PET stands for what? Potential evapotranspiration. Potential evapotranspiration means what? You have got the potential to score number 1 rank in the exam, but we always underperform. We don't study due to obvious reasons. We have got the capacity and capability to score number 1 in the exam, but we don't realize our potential. We always underperform. Whatever actual performance that we give, that only matters. People appreciate that only, isn't it? I got a potential to score number 1, but I end up with a 100 rank. People will not appreciate me. So my actual is equal to potential, then only they appreciate, isn't it? You just have potential, it is of no use. Understood? Potential means it is capacity and capability. That means what? When best of the things happens to you, you prepare well for the exam, you work really hard, you really use good material for your exam. Good study material is given to you. You work really hard. You don't operate the cell phone. You don't watch TV. You 24 hours. You think of your exam only. Then 100% and your health is in good condition. Right? No one is disturbing you. Financially, no problem to you. You don't have any tensions, mental tensions or any tension. Then your actual performance is equal to your potential performance. Isn't it? But obviously what happens? We are all human beings. Sometimes we suffer with health problems. Sometimes financial support may not be there with us. Even though I wish to study, but I don't have any proper financial support. Because of that, some people, they can't concentrate on their studies. And sometimes what happens, then your teachers may not teach well. You are really interested to learn, but your teachers, they don't teach properly. And you don't have proper, or you have got some health problems. They are not permitting you to focus and carry out these studies properly. So because of obvious reasons, what happens, many of the times we underperform. We don't realize our potential. So whatever actual result that we produce, that only people appreciate. So potential nobody appreciate, isn't it? So therefore, exactly in the same way, when best of the things happens, whatever evapotranspiration occurs, that is called potential. And reality, whatever evapotranspiration occurs, that is called actual. But what is important to you? Actual is important or best? Actual only important. Actually, how much amount of water evaporating, that is important, isn't it? But unfortunately, you can't find out actual evapotranspiration. Whatever conditions are there today, tomorrow the conditions are different. So whatever evapotranspiration occurred today, tomorrow it may not occur same. Therefore, it is actual conditions keep on changes from time to time, place to place. Therefore, very difficult to arrive at actual evapotranspiration. Therefore, what we do is we try to work out potential by using some kind of relation, we try to establish relation between potential and actual. With the help of that relation, we try to arrive at actual evapotranspiration. Therefore, potential evapotranspiration means what? Is evapotranspiration which would occur when soil contain adequate moisture to meet the vegetative needs of the ground, and ground is covered by full vegetation. Ground is full of vegetation and soil is containing full water. During that period, whatever evapotranspiration occurs, that is called potential evapotranspiration. Reality, sometimes the ground may not be having sufficient amount of water. Ground is covered by full vegetation. Vegetation is there, right? But no water in the ground, right? Full water is there in the ground, but there is no proper vegetation on the surface of the ground. During that period, whatever evapotranspiration occurred, that is not the potential, isn't it? That's the actual. So actual is not equal to potential. Sometimes it is equal to potential, sometimes it is less than potential happens, actual. So evapotranspiration that occur when soil contain adequate moisture to meet the vegetative needs of the ground. Covered by full vegetation. Ground is full of vegetation and soil also full of water. During that period, whatever evapotranspiration occurs, that is called potential evapotranspiration. Live vegetation is known as PET. What is AET? Actual evapotranspiration. So evapotranspiration that occur at a given time at a given place is known as actual evapotranspiration. Evapotranspiration that occur at a given time and at a given place under specific conditions is known as actual evapotranspiration. Then our interest is what? Finding AET only. Therefore, you cannot work out AET straight away by using it. We don't have any mathematical equation to work out AET. We have mathematical equation to work out PET. Okay? Potential, anybody can say that. I can say that I have got a potential to score number 1 rank in the exam. That is easy to say. But what actual rank I get in the exam, nobody can say. Isn't it? It all depends. How my preparation, how I prepare for the exam, what depth I prepare, what kind of study material I used, what kind of coaching I got from the teacher. If the teacher taught him well or not. It all depends. It's exactly same way. Real conditions are difficult to realize. Well in advance I am talking. So therefore, we try to find out actual evapotranspiration with the help of potential evapotranspiration. So estimation of AET. How AET can be estimated. Our interest is finding AET only, not PET. Okay? AET is found by knowing PET and moisture content of soil. Okay? If actual moisture content of soil is known to you, you can find out PET. PET and moisture content of soil, both of them are known to you, you can find out AET value. If moisture content of soil is at field capacity, if moisture content of soil is at field capacity, FC means it is field capacity, MC means moisture content, water content. MC means moisture content or water content. FC means field capacity. What is field capacity in irrigation? Your sir might have taught you. Field capacity is nothing but it is the maximum water retained by the soil against the force of gravity. How much water soil can accommodate maximum, that's called field capacity. Beyond field capacity, moisture content is there, it is of no much use. So if moisture content is equal to field capacity. One more thing is PWP, that's called permanent wilting point. Permanent wilting point. If moisture content of soil is at field capacity, then AET is equal to PET. Okay? If moisture content of soil is less than field capacity, then AET is less than PET. If moisture content of soil is at permanent wilting point, then AET is equal to 0. Therefore, in general, AET value vary from anywhere between 0 to PET. Okay? It may vary anywhere between 0 to PET. That means you work out AET by PET ratio. Note. In general, you work out AET by PET ratio varies anywhere between 0 to 1. Okay? Anywhere between 0 to 1. So if AET is equal to PET, what is AET by PET ratio? 1. So in this case, AET by PET is equal to 1. In this case, AET by PET is less than 1. In this case, AET by PET, AET is 0, no? So AET by PET also 0. So in general, AET by PET ratio varies anywhere between 0 to 1. So that point. So if you know that PET value, multiply this with this ratio, then you can find out AET. AET is equal to PET times that fraction value. So generally, in general, AET is always less than or equal to PET. It can't be more than PET. Okay? That's the point which you need to remember. Or PET always greater than or equal to AET. That we also can write. Okay? That's all. This is one thing. So we have got procedure to work out PET, but we don't have any procedure to work out AET. So let us see how PET can be estimated. So methods to measure. Methods to measure and estimation of PET. So first one is, we have got one method, physical method, that's called lysimeter. We also got some empirical formula. Among them popular are Penman's equation. Using Penman's equation you can work out, or Blahnik-Riddle formula, which is very popular among the civil engineers because it's so simple and easy to apply. So Blahnik-Riddle formula is very, very popular. Okay? So lysimeter is a device used to measure evapotranspiration. Lysimeter is a device used to measure evapotranspiration. Okay, if you see the lysimeter, it also contains one container which is porous from the bottom but impervious from the sides. Porous from the bottom means what? There is a provision to collect water. So that means you have got a perforated plate made with holes at bottom. This is filled with the soil. This is filled with the soil container. This is soil, and we grow some plants inside this. At one particular stage of plant growth, we start experimenting. Okay? So we add some water inside this. Water added. Okay? We don't cover the top because we allow ground evaporation also. So some water evaporate through plants, some water evaporate through ground. So both of them together known as evapotranspiration. Ground also, soil also water evaporates through plants or leaf, through the leaves of the plants also water evaporate. Some water, if it is more than field capacity present inside the soil, then that water leak here. So that water accumulate at the bottom and we collect here. This is taken as inflow, this is outflow. So when evapotranspiration occurs, change in storage also happens inside the soil, water storage. So therefore from here we can find out evapotranspiration. So evapotranspiration is equal to, it is inflow minus outflow minus change in storage in the soil. Change in moisture content otherwise. Change in moisture content of soil. Mass balance equation, we are writing around this container. You can write change in moisture content of soil. So moisture evaporates from the ground, what happens? Water moisture content, it decreases or increases? Water leaves the soil, water leaves the plants. Initially added I amount. So delta MC is water left the soil. Then what is the O value? Less than I value. So therefore delta MC is less than I value. Delta MC plus O is equal to I. Understood? So delta MC is moisture left the soil. So we need to measure that. So from this we can find out evapotranspiration. The setup is called lysimeter. This is a device known as lysimeter. Then Penman's equation, little tough to apply because it is a thermodynamic approach. He coupled both law of conservation of mass and as well as law of conservation of energy. So therefore he proposed one equation, potential evapotranspiration is equal to, it is potential evapotranspiration is equal to Penman's equation it is. Straight away you can work out potential evapotranspiration. A into Hn plus E gamma by, it is A plus E. Okay? A into Hn plus E gamma by A plus E. A plus gamma, sorry. Understood? Just is empirical formula proposed by somebody. So in this Hn is equal to, only the thing that you need to work out is Hn. That Hn is nothing but net radiation of a place. This you have to work out based on thermodynamics. Net radiation received, this is. Right? Then A, E, gamma are constants. A is known as, it is a slope of PS versus temperature curve. Saturation vapor pressure versus temperature curve. So saturation vapor pressure, temperature curve if you plot, saturation vapor pressure versus temperature plot if you make, so it will be like this. And slope of that curve is called A. So this is known as, slope of this curve is called A. Then E gamma is known as psychrometric constant. It is also a constant. And E is known as, it is also a constant which account both wind speed and difference between PS and PA. Both of them are taken into account by this constant. So remaining all are constant except this net radiation required. This you have to work out. So that is little difficult, complex term. For civil engineers it is difficult, therefore it is not so popular approach among the civil engineers. Then next easy simple approach is Blanik-Riddle formula. And this is very popular approach used by the civil engineers. So potential evapotranspiration straight away will get, it's on so inch per month because it's empirical formula, units are very very important. Straight away you can work out so and so inches per month by using equation kPtm by 100. This is very popular. Even irrigation also you come across with this. So this K is known as crop factor or consumptive use factor. So this crop factor vary from crop to crop. For rice crop, K value is different. For sugar cane, K value is different. For wheat, K value is different. Crop to crop, it may vary. Not only for crop to crop, for a given crop also, at different stages of crop growth, K value changes. 50%, 20% crop stage, 20% growth stage, K value is different. 50% growth stage, K value different. 100% growth stage, K value different. So, human beings also, small kid, how many liters of water he drink? Small kid, half liter maximum, half liter, 1 liter. Person like me, I require daily 4-5 liters to drink for my survival. To maintain my body metabolism, I need to drink 4 to 5 liters of water. So it all depends on person. What stage of growth is there? Is young, small kid, infants drink less water. So as grown up kids, they drink more water. As age increases, their water consumption also increases. Exactly same way crop also. So at early stage, budding stage, it consumes less water. At full growth stage, it consumes more water. Half growth stage, consumption is different. So it varies from crop to crop and as well as the stage of crop growth. That also important. So that is anyway, that will be given in the question that we read from the tables and all. You are not expected in exam, therefore K value will be given to you. P is known as percentage daylight hours in a month because it's calculate monthly evaporation, transpiration. So percentage daylight hours. How many hours daylight is there? So during daylight only transpiration occur, isn't it? Daytime only it happens. How many daylight hours are there? This daylight hours changes from month to month. Normally in summer we have got more daytime, less night times. In winter we have got more night times, less daytimes. So winter early morning till 7 o'clock you don't find sun. Summer by 5:30 only you will find the sun in the atmosphere, isn't it? Summer sun will go. Sunset will happen very late. Till evening 7 o'clock you will find sun in the atmosphere. But whereas in winter, you will come late and you will leave early. That means number of daylight hours in winter is less, number of daylight hours in summer is more. So that is also important. At what time we are calculating this? This is also important. Summer you are working out or winter you are working out. Percentage daylight hours in a month. And TM is known as mean monthly temperature. In degree Fahrenheit. You have to substitute this degree Fahrenheit. This is in percentage. Crop factor, no unit. Therefore, straight away you will get answer in inch per month. Once you get inch per month, you can convert into this into mm. 1 inch is equal to 2.54 centimeters or 25.4 mm. You can convert in mm per month or centimeter per month as per your comfort and convenience, because inch business is not there in India. That is British system. Now we are using only mm, centimeters and millimeters. Okay, that's all. Just formula substitution, kPtm by 100. So this K value you can also work out by using equation. It is consumptive use by pan evaporation. What is consumptive use? There are two types of water usages. One is called consumptive use, other one is called non-consumptive use. Consumptive use means what? When you supply water for one purpose, in serving that purpose, if water has been consumed, then it is called consumptive use. Suppose for example you take drinking. When you drink water, can you get back that water again? No way. Once for all it is over. So drinking is a consumptive use. Similarly bathing. When you take bath, again you can collect that water, bath water, isn't it? You just pour water. Your body will not consume that water. So therefore bathing is non-consumptive use. Drinking is consumptive use. Exactly same way. The water applied for irrigation crops is a consumptive use. Water used in hydropower generation is non-consumptive use. Hydropower generation, what happens? Water will go and hit the turbine runner. So after hitting the turbine runner, water is collected as it is. That water you can use for some other purpose. So consumptive use, non-consumptive use. Consumptive use means what? When you supply water for one purpose, in serving that intended purpose, if water is being consumed, then it is called consumptive use. When you supply water for one purpose, in serving that intended purpose, if no water is being consumed, it is called non-consumptive use. So irrigation is example for consumptive use. Hydropower generation is an example for non-consumptive use. I am talking about civil engineering terms. Okay. Consumptive use by pan evaporation also will give K value. So K value vary from crop to crop, and not only crop to crop, it also depends on stage of crop growth. That also decides K value. Anyway, so this potential evapotranspiration and consumptive use, both of them are interchangeable terms. Sometimes this consumptive use greater than or equal to potential evapotranspiration. So consumptive use is equal to potential evapotranspiration when water consumed by the plants is neglected. When water, because plants consume very less water, more water they transpire. Plants consume very less water during plant metabolism, that is photosynthesis. During photosynthesis they consume very less water in preparing plant proteins and plant nutrients. But most of the water it let into atmosphere as a vapor. Therefore, when water consumed by the plants, most of the times we neglect. When water consumed by the plants are neglected, consumptive use and potential evapotranspiration, both of them are one and same. So while estimating consumptive use, water consumed by the plants considered, then consumptive use is slightly more than evapotranspiration, potential evapotranspiration. So sometimes it is equal, sometimes it is consumptive use is greater than potential evapotranspiration when water consumed by the plants are considered while estimating consumptive use. When water consumed by the plants is considered. If it is neglected, both of them are one and same. While estimating consumptive use, if it is neglected, both of them are one and same. When it is considered, consumptive use is different, potential evapotranspiration is different. Therefore, when water consumed by the plants are neglected, consumptive use is equal to potential evapotranspiration. So we can use same formula kptm by 100. That's all. This much idea is there. Any numerical in exam you can work out related to potential evapotranspiration. That's it. There end matters. So completed this topic, evapotranspiration. So let us work out few numericals related to evapotranspiration before we jump into what? Jump into infiltration. Now listen, one more thing. So we also work out aridity index based on PET by AET ratio. So based on PET by AET ratio, aridity index we work out. It's called AI. We'll work out civil engineer working with government departments. They're asked to work out aridity index. Based on this aridity index, they can put forward some proposals to government to help the farmers living in that area, farming sector. Suppose farmers, they don't get proper crops because of scanty rainfall, because of no rains, they don't get crops. Their farmers are backbone of our country. So it is the duty of government to help them. So farmers get a helping hand from the government based on recommendations made by civil engineer. Civil engineer, how he recommend? Based on aridity index. He has to work out scientifically, not he can't recommend, so this fellow person is to be helped, that person is to be ignored, not like that. Based on aridity index of that region, then farmers in that region get helping hand from the government. Okay? So this aridity index is nothing but, it is difference between PET minus AET by PET into 100. So work out PET and AET, find the difference. The difference between PET minus AET by PET into 100 will give aridity index. If aridity index is greater than 50%, right, that region experiences drought or drought, whatever it may be, because they experience severe drought, severe. That means no rainfall happens in that area. Farmers they don't get crops properly. Therefore, they badly need help from the government. Severe drought. If aridity index is between 25% to 50% range, so the experiences moderate drought or drought, otherwise moderate drought. If aridity index is less than 25%, right, the experiences mild drought. So depending upon what type of drought they experience, government will help them. So this point also, sometimes in ESE exam they are asking this aridity index value. So aridity index is the basis for helping to decide whether that district or whether that state is a drought, experiencing drought or no drought. Okay? Severe drought, moderate drought and mild drought. That's all, sir. So let us work out few numericals related to this topic. Okay, example, because GATE is more of numerical oriented. Example 1, for a particular place, in the month of November, the percentage sunshine hours is 7.2. Daylight hours, sunshine hours means. Definitely it is not in India, somewhere else in the world, and mean temperature is 18 degrees Celsius. Monthly mean temperature is 18 degrees Celsius. If the consumptive use coefficient for the crop is 0.7. If the consumptive use coefficient, what is that K value? Consumptive use coefficient for the crop is 0.7 for that month. Find the consumptive use of the crop in mm per day. So you've been asked to find out in mm per day. Options are given to you. A is 1.54, B is 2.56, C is 2.74, D is 3.2. Come on, what is given to you? Right? K value is given. K value is given as 0.7. Percentage daylight hours are given as 7.2. Mean monthly temperature is given as 18 degrees Celsius. But you have to substitute this value in, right, degree Fahrenheit. How to convert degree Celsius to degree Fahrenheit? So degree Fahrenheit minus 32 by 180 is equal to degree Celsius by 100. So how to convert degree Celsius to degree Fahrenheit? So degree Fahrenheit, temperature in degree Fahrenheit is equal to, it is 1.82 C plus 32. So temperature in degree Fahrenheit is equal to, it is temperature in degree Celsius plus 32. 1.8 times temperature in degree Celsius plus 32. So degree Celsius how much is given? It is 18 plus 32. Understood now? If you are confusing, I'll put temperature over there. So temperature in degree Fahrenheit is equal to 1.8 times temperature in degree Celsius plus 32. So 1.8 times 18 plus 32. Come on, work out. 1.8 times 18, how much it is? Calculators are allowed in the exam, so you need not worry. Plus 32. It is 64.4 degree Fahrenheit. So 64.4 degree Fahrenheit is. That's all. Now potential evapotranspiration is equal to consumptive use is equal to, it is Kp Tm by 100. Sometimes both of them are same only, right? Therefore consumptive use is equal to K is 0.7, P is 7.2, 64.4 by 100. You will get answer in which unit system? Inch per month. But I have been asked to work out answer in which unit system? Mm per month. How to convert inch into mm? 25.4 mm per day. How to convert which month this is? He has given in the month of November. November how many days? How many days are there for November month? 30 days. So number of days in November month is equal to 30. Therefore I will divide by 30 this. Then I will get answer in mm per day. So November month In November, January month, if they ask, how many days you have to take? 31 days. In November, number of days is equal to 30. That's why 30 divided. That's it. Straight away you can work out in mm per month. So 0.7 into 7.2 into 64.4 by 100. So it is 3.24 inch per month. This I am converting into mm per day. So it is 2.748. 2.748 mm per day. It's almost 2.75 mm per day. So let us see the options given there. 2.74 is there, no? So you can tick mark this. Okay? That's how you have to work out. So any question you can work out. It is only formula substitution, nothing is there. One more try, you want to try, you can try. Example 2. You want to try one more? At a particular area, pan evaporation for the January month. So January month, how many days? 31 days. Is 9.5 centimeter. For a stage growth of, for a particular stage of plant growth, for a stage growth of 40% of the wheat crop, 40% growth stage is asking you to calculate for wheat crop. The consumptive use coefficient is, that is K value. .52. What crop corresponding to 40% growth for January month is? Then the daily consumptive use. Then the daily consumptive use of the wheat crop. That is indirectly asking evapotranspiration. Crop evaporation is nothing but evapotranspiration only. Wheat crop corresponding to 40% stage growth for January month is. Options given are 1.6 mm per day, B 0.4 mm per day, C 0.637 mm per day, D 4 mm per day. Come on, work out. So what is given? Pan evaporation for January month. Monthly pan evaporation is given. Pan evaporation in January. So total amount of water evaporated in January is 9.5 centimeter. Then K value for 40% growth wheat crop, 40% growth stage is 0.52. Okay. 1 minute. Just 1 minute. हेलो हेलो यस यस बोलो बोलो भैया हाँ ठीक हो यस यस आई एम गुड या आई एम वेटिंग फॉर योर कॉल यस 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 Yes, correct. Yeah. Okay. I'll call you after some time. You are now teaching in the class. Okay. Unacademy, I'm teaching. Okay. I'll off 1 hour. Okay, K value is given as 0.52. Sorry for interruption. It's important call it is. That's why I answered. So K value is 0.52. Corresponding to 40% for January month. Okay. K is equal to 0.52. Pan evaporation is given. Then he is asking consumptive use for January month. So number of days in January month is, because you have been asked to find out this individual system mm per day. Okay, in January is equal to 31 days. Therefore, this equation you cannot use. P is equal to C is equal to Kp Tm by 100 because P is not given, Tm now is not given. There is another way to work it out. This is K value is known. K value is equal to, it is consumptive use by pan evaporation. So from here also you can find out consumptive use. So consumptive use is equal to, it is K times pan evaporation. So K is given as 0.52, pan evaporation is given as 9.5. So you will get centimeter per month. So but you have been asked to work out, right, in mm per day. So how to work out centimeter to mm? How to work out? Centimeter into mm, 0.552 into 9.5 centimeter per month. How to convert centimeter into mm? 10. 10 mm is equal to 1 centimeter. So 1 centimeter is equal to 10 mm. How to convert month into days? 1 month is equal to January month, 31 days. Therefore by 31. Then it become mm per day. That's it. So it is 0.52. 0.52 into 9.5 into 10 divided by 31. So it is 1.593 mm per day. So it is rounded to 1.6, almost to 1.6 mm per day. That's how you can round it up. Sometimes 1.59 is given, well and good. So options, let us see options, what is given? 1.6 is given because it is rounded. So option A is correct option. So this is how we can work out. Yeah, any doubt is there, you can post your comments there. I will address your doubts. I will address your doubts, okay? So this is how we can work out potential evapotranspiration. Next, let us move to next topic. So it's completed. I hope it is clear to you. So only one formula I have to remember, this formula. So whatever I have put in boxes, this formula I have to remember. So I have given here consumptive use by pan evaporation is equal to K. He has given pan evaporation, he has given K value. Therefore, indirectly we can work out consumptive use. Okay? So whatever I put in the these rectangular boxes, that information is important for exam point of view. Understood? Okay then. No doubt, sir. No doubt. Wow. Doubts are not there. Understood completely. King of Prince. Okay then, King of Prince. Thank you very much. Next, let us see the next important topic is infiltration. Infiltration. So whenever the rain occurs over a ground, the first loss that it experiences is infiltration. Soil is dry, soil is there, and a dry soil, so when rain happens, what happens? Soil absorb water. Why it absorb water? Because the pore space of the soil is deficient of water. When water evaporates from there, again somebody has to fill that water, isn't it? Who will fill that water? Rain only. So therefore, to meet that soil moisture deficiency of the soil, so soil start absorbing water. Okay, that is called infiltration. Truly speaking, unlike other losses, infiltration is the first loss. So infiltration is the process by which water get into ground to meet soil moisture deficiency. This is a ground. Dry soil is there, over which heavy rainfall occur. What happens? This is a ground, for example. Heavy rainfall occur. Rain occur over a ground. Then what happens? The first loss it experiences some water soak into ground and absorbed by the ground. That is called infiltration. Water getting into ground is called infiltration. Why it get into ground? Because this ground is deficient of moisture. So when ground get exposed to sun, all of the water present in the ground that evaporates. So therefore, the pore space of the ground is completely devoid of water. So to fill that pore spaces with water, so soil start absorbing water. That is how groundwater will form. From ground also we get water, isn't it? How you get groundwater? Because of filling only. If there is nobody fills the ground, then how we get groundwater? You don't get any groundwater, isn't it? So this is called infiltration. After meeting the soil moisture deficiency, if any excess water remain inside the ground, that will not again get out of the ground, because against gravity it can't travel. With gravity it is easily can get into ground, but it cannot rise up again. So therefore that water flow deep inside the ground and join groundwater table. So the deep vertical movement of water inside the ground is called percolation. What is called? Technically it is called percolation. Water percolate deep inside the ground and finally join what? Groundwater. So this is called groundwater. That is how groundwater will form. And this line, dotted line I have plotted now, that's called groundwater table. Okay, this is ground. So soil, the water getting into ground as soon as rain commences is called infiltration. So infiltration is the method by which water get into surface strata of the earth. Infiltration is the method by which water get into surface strata of the earth. Earth means ground, surface strata of the ground. To meet what purpose it go there? To meet soil moisture deficiency. Suppose you are earning 100%, 100 rupees, but you are very hungry. When you are hungry, but you earn 100 rupees, what you do first? You try to meet your hunger, isn't it? So you try to buy some food to meet your hunger. So after meeting your hunger, some excess money left with you, then you can help others also. Without meeting your hunger, you can't help others, isn't it? Keeping yourself starving, you can't offer food to the others. Once your belly is completely filled with food, any excess food remain with you, that you can donate to the others, isn't it? Because food you cannot keep. Suppose leftover food is there, if you keep with you, that will decompose. You have to throw it out in a dustbin. Instead of throwing in a dustbin, you can help others by feeding it to the needy people, isn't it? So when you try to feed others, when first of all your belly has to be filled, isn't it? You buy some food, your belly is completely filled. If any excess food remain with you, then you can offer that food to the others. Exactly same way. Understood? Clear now? You are not responding. To meet soil moisture deficiency. Soil moisture deficiency is something like a hunger for a human being. Human beings are hungry because they are not eaten food for a long time. Then what happens? As soon as food is offered to them, they absorb first. First they try to eat. After eating, then any excess food remain them, that only given to the others. Isn't it? Exactly same way. Clear now? After meeting the soil moisture deficiency, if any excess water remain in the ground, that percolate and join groundwater table. That's how groundwater will form. Okay? Oh, sorry, this color not visible to you. So after meeting soil moisture deficiency, my stomach is waiting to crack GATE exam. Yes, definitely that hunger should be there. Then only you can perform better. You try to work hard to earn your livelihood, to meet your hunger, isn't it? Good, good, good. After meeting soil moisture deficiency, if any excess water remain in soil, remain in ground, percolate, remain in ground, flow vertically below ground and join groundwater table. Flow vertically below ground and join groundwater. The deep vertical movement of water is known as percolation. Deep vertical movement of water inside ground is known as percolation. So percolation, no, there is no special topic percolation. Why there is no topic called percolation? Why we are not talking about percolation? Because it is infiltrated water only percolate. You are estimating infiltration means indirectly that also include the water flow deep inside the ground as well, percolation as well. Therefore again no need to specially mention about percolation. Okay? Good. Then I will introduce two technical terms related to infiltration. One is called infiltration capacity, which is denoted by FC. Infiltration capacity is defined as the maximum rate at which soil is capable of absorbing water is known as infiltration capacity. When you eat maximum food when you consume, when you are very hungry and your favorite food is there before you. Huge amount of your favorite food is offered to you, right? When you are so hungry, that time what happens? You start eating with 2 hands, isn't it? Your favorite food, you are so hungry. So you can't expect anything more than that. Then you start absorbing more. So exactly when ground is fully dry, when heavy rainfall occur over a ground, during that period, ground absorb maximum water. That is called infiltration capacity. But every day it can't absorb like that. Today rain occur, tomorrow also again rain occur. Today rain occur, some moisture already remain in the ground. All of the moisture immediately, instantly get out of the ground, isn't it? So it is already, somebody offered me food. Again some other person, my friend also called to his house. Again offer me food. I can't eat to my capacity, isn't it? Already partially my belly is filled with food. So remaining portion I fill, isn't it? So during that period it is not infiltration capacity. So infiltration capacity means what? The maximum rate at which soil is capable of absorbing water. When it absorbs maximum rate, when ground is fully dry, when heavy rainfall occur over a ground. Rainfall is something like a food, right? That soil remain dry is nothing but a hunger. Okay? You are very, very hungry and your favorite food offered. You can't expect anything more than that, isn't it? Exactly same way. So maximum rate at which soil is capable of absorbing water. Is known as infiltration capacity, denoted by FC. Second one, infiltration rate or rate of infiltration. Capacity is different, rate is different. It is the actual rate at which water is absorbed by the ground. Actual rate, water is absorbed by the ground. This is denoted by FA. Okay, I'll write, sorry. It is denoted by FA. Some symbols we are denoting these things by some symbols. This is denoted by FA. The actual rate of infiltration at a given time and at a given place under specific conditions. Is known as infiltration rate. So what is important to you? Infiltration rate only important. Okay. Actually, what amount of water soak into ground, what amount of water absorbed by the ground, that is important. So therefore we need to work it out. So estimation of FA. What is FA? Infiltration rate. So infiltration rate FA is estimated by establishing relation between infiltration capacity and intensity of rainfall. So FA is estimated by establishing relation between FC and I. What is I? Intensity of rainfall. So first, for storms of intensity greater than or equal to FC, when they occur above the ground, then during that period the FA is equal to FC. I is greater than or equal to FC, FA is equal to FC. When I is less than FC, then FA is equal to I. Understood? This is important relation you have to remember. That means what? You are capable of eating 5 idli. That is your capacity. Your belly can fill with 5 idli. Idli. Breakfast. When you are so hungry, right? Your belly can accommodate 5 idli. But somebody offered 10 idli to you. How many idli you consume? I is number of idli offered. This your capacity. Then how many idli you consume? So 10 idli offered. Your capacity is only 5 idli. How many idli you consume? 5 only. Understood? So somebody offered only 2 idli, but your capacity is 5 idli. How many idli you consume? All the 2 offered to you. Exactly. Here idli offered is nothing but rainfall, intensity of rainfall. Idli consumed is FA. Our capacity is FC. How many idli I can consume? That is my capacity is FC. When I am hungry, I can consume 5 idli. So I am not partially hungry, I can consume less than 5 idli. Similarly, when soil is dry condition, then it consume water to its full capacity. Soil is partially wet condition, it consume less only. Therefore, how to find out FA? Sometimes FA is equal to FC, sometimes FA is equal to I. When I is greater than or equal to FC, FA is equal to FC. When I is less than FC, FA is equal to I. Very, very important relation this is. So while working out numericals, we use this. Okay? Remember. Idli example you remember, you can remember easily this. Okay? Next. Methods to measure and estimate infiltration. So there are some devices which are used to measure infiltration. They are called infiltrometers. Physically we can work it out. Infiltrometers are used for field measurement of infiltration. Straight away in the field you want to measure, you can use it, infiltrometers. For field measurement of infiltration, we use infiltrometers. In the laboratory also you can measure infiltration by using rainfall simulator. Rainfall simulator is used. Laboratory measurement of inside the lab you can measure. Laboratory method of measurement. Okay, and third method is numerical methods. They are very, very important for exam point of view. Of course, basis is experimentation only. So third method is Horton's infiltration capacity curve. Using Horton's curve, we can measure infiltration, how much water infiltrated into ground. Horton's infiltration capacity curve is used to work out infiltration. Similarly, we also have infiltration indices. These two are mathematical approach, numerical approach. Indices. So these two are very, very important for exam point of view, and these are laboratory models. So normally they don't ask. So infiltrometers, again we have got single ring infiltrometer, you have double ring infiltrometer. So that is used in the field straight away. So let us skip that part. That part is not required for us because ours is a revision course. So let us go with the straight away numericals. How to work out numericals based on Horton's infiltration capacity curve. Horton's infiltration capacity curve. So this Horton is the first person who conducted infiltration studies on soils. He conducted infiltration studies on different types of soils based on different rainfall intensities. Okay, sandy soils, clay soils, loamy soils, sandy clay soils, sandy loamy soils, right? All kinds of on all types of soils he conducted experiments in his laboratory by simulating a condition I greater than or equal to FC. And when the observations of his laboratory observations, when he plotted with respect to time, the plot obtained is called infiltration capacity curve. So by carefully process that curve, if you analyze that curve, you can realize both infiltration and as well as runoff. Even runoff also can be estimated. So Horton has conducted infiltration studies at his laboratory. For condition, what is that condition he maintained? I greater than or equal to FC. In the laboratory, any kind of rainfall you can create. Artificially you can create a rainfall. Okay. So when the results of his observation when plotted with respect to time, then the plot obtained is known as, then the curve obtained is known as Horton's infiltration capacity curve. Horton's curve. Okay, simply I am writing Horton's curve. If we see his curve, it will be like this. This is a plot between infiltration capacity and time plot. Okay, this is infiltration capacity. What is that? FC versus time. FC at a different time intervals you can work out. Okay, if you see that infiltration capacity in the beginning, when you are very hungry, in the beginning you start eating food at a maximum rate. So as time progresses, what happens? Slowly your stomach starts filling with food, then you become slow. Exactly same way ground also. In the beginning of the storm, so much water get into ground. As storm duration increases, then infiltration capacity also slowly decreases and attain a asymptotic value. It doesn't become 0 at a time, but it slowly becomes 0. So infiltration capacity is maximum at the beginning of the storm. As storm duration increases, not asymptotic, sorry, it attains a constant value after some time. Asymptotic means slowly it becomes 0. Constant means it remains constant. Maximum at the beginning of this time. After some time what happens? It attains a constant value and remain with that value indefinitely. Understood? This is called infiltration capacity curve. Infiltration capacity curve at time t is equal to 0. This is 0 time. It is taken as FC0. At any time t, you work out infiltration capacity curve, ordinate of that curve. At any time t, infiltration capacity is equal to FCT. Once it attains constant value, that constant value is called steady state value. It is called FC. So it is infiltration capacity versus time plot, right? So this curve is known as Horton's curve. This curve is defined by equation. Infiltration capacity at any time t is equal to, it is FC plus, it is FC naught minus FC into e power minus kt. This is also given by Horton only. By carefully analyzing this curve, subjecting this curve to mathematical treatment, he found that infiltration capacity at any time t is equal to, it is FC plus FC naught minus FC into e power minus kt. So that equation is called Horton's equation. Horton's equation for infiltration capacity curve. So Horton's curve is defined by equation. Horton's curve is defined by infiltration capacity at any time t is equal to FC plus FC naught minus FC into e power minus kt. So in this equation, FCT is known as what? Infiltration capacity at a time t. FCT is known as infiltration capacity at a time t is equal to t, at any time t. At any time t. But Horton approach is true for condition. What is that condition? This equation is true when I is greater than or equal to FC. Then only it is correct. When I is less than FC, Horton approach fails. Okay? Infiltration capacity at any time t. What is FC naught? Initial infiltration capacity. Initial infiltration capacity. That is at time t is equal to 0. That is infiltration capacity at a time t is equal to 0. What is FC? Steady state infiltration capacity. Steady state means what? Constant value. Steady state infiltration capacity. Once it attains steady state, it remains in that state indefinitely. Steady state infiltration capacity or constant capacity. Okay? Once it attains steady state, indefinitely it remains in steady state. No change happens further. So till it attains steady state only, it keep on decreases, exponentially decreases as time increases. After some time, it attains a constant value, remain in that with that value indefinitely. Okay, that's all. This is the equation. So using this curve, we are supposed to work out infiltration and as well as the other things. Now how to work out infiltration using this curve, let us see. This is infiltration capacity. We are not interested in finding capacity. We are finding, our interest is finding how much water soak into ground. That is important. That is infiltration. Okay. Now let us see. Estimation of infiltration using Horton's curve. See now Horton's curve, what is the infiltration capacity versus time plot, right? At any constant value. At any time t, the infiltration capacity is FCT. One more small time interval in dt, if I measure, there's no much change between them. It is FCT only. Small change in time, dt value. If I take this one, so there is no much change. It is FCT only because it's time interval being so small. This FCT and this value remain same. So therefore, if we measure infiltration capacity is nothing but infiltration in a given time. Infiltration in a given time into time will give infiltration. That means what? Area under this curve. So this FCT into dt is equal to infiltration at a time dt. So infiltration at any time dt is equal to, at any time dt is given by equation, it is FCT into dt, which is nothing but area under Horton's curve. Area under Horton's curve at a time dt. Okay? At time dt you measure area under Horton's curve, you will get infiltration. You want to get total infiltration given time t, then what you need to do? You have to integrate that equation. FCT means what? It is FCT equation. That is FCT value is nothing but is FC plus FC naught minus FC into e power minus kt. This equation into dt, that will give infiltration at the time dt. Okay? So you want to measure total infiltration in time t. So what to do? Total infiltration in time t is equal to, right from the beginning of this term, if you take workout, then you have to integrate that equation. So total area under Horton's curve up to time t. So how to measure total area under Horton's curve? Integrate 0 to t FCT into dt. That FCT equation, if you integrate 0 to t, is FC plus FC naught minus FC into e power minus kt into dt. If you integrate, then you will get total infiltration in time t. Okay? This is what you need to remember finally. Especially in GATE exam, calculators are allowed. Therefore, you are expected one question from this topic. 0 to t, FC plus FC naught minus FC into e power minus kt. That is FCT value. This you have to integrate with respect to t, dt. That's all, sir. Sometimes without integration also you can find out, provided that if it attains steady state. After attaining steady state, the area under curve you can divide into two. One is parabola, other one is rectangle. So you measure area of rectangle plus area of parabola. That will give total area under curve. That will give infiltration. So without infiltration you can work out, provided that it after attaining steady state. After attaining steady state, that means after attaining FC value, constant value, no change is happening with respect to time, then you can work out. After attaining steady state, area under Horton's curve divided into rectangle and parabola. Okay, after attaining steady state, what we do? See now, I am plotting once again. This is Horton's curve. After attaining steady state, suppose you are working out somewhere here at a time t. What you need to know? You have to measure area under this curve. How to measure area under this curve? I will divide this area into two parts. One is rectangle, the other one is parabola. So now it is attaining steady state where? Here, somewhere here. It becoming constant. It becoming constant somewhere here. Beyond this point you are working out? Yes, you can divide into, before that point you can't divide. You have to integrate only. So this you can divide into rectangle. What is steady state value? What is steady state value here? After attaining steady state, what is this value? FC only. After attaining steady state, value doesn't change. It remains as FC only. Okay? So, before steady state only, it keep on changes. So, this area, I'll take it as A1. Okay? This area I will hatch. This hatched portion is rectangle. What is the area of rectangle? So, it is length into height or width into height. This is area of rectangle. This parabola. This is A2 portion. This is A2. That hatched portion is parabola. So area under curve you can divide into rectangle and parabola. So total area under curve is total infiltration. So total infiltration in time t is equal to. Sometimes it will be helpful to you after steady state you work out without integration also you can find out. Is equal to A1 plus A2. So total infiltration is equal to A1. What is A1? What is A1? It is FC into T. Rectangle, no? Area of rectangle, FC into T. FC is height of this one, this is width of this one, FC into T. T minus 0, T only. A2 area of parabola this is. So we take it for granted for time being FC naught minus FC by K. That is the area of parabola. So total infiltration in time T after attaining steady state. After steady state, you can work out without integration. Before steady state, no option, you have to integrate only. Okay? So this one more, you can save some time in the exam, provided that if you know steady state condition happened before working out, then you can make use of this. Both will give same answer. This and this will give same answer. Okay? After attaining steady state, integral 0 to t, it is fc plus fc naught minus fc into e power minus kt into dt. If you integrate this equation, okay, and if you work out this value, both will give same answer. fc naught by, understood? So sometimes it is advantage for us without integration also you can work out, provided that if you confirm yourself that ground has attained steady state. But before steady state, no, you have to integrate only, no option left with you. Understood? If steady state information is there, you can make use of this. So this is where this topic only tough topic to the students to understand. Okay? And now, we can also work out runoff component with the help of this one. Infiltration you can find out. Second thing what you can work out is runoff. Estimation of runoff using Horton's curve. So what you need to do is to estimate runoff. So you require one rainfall hydrograph is required. So if you superimpose Horton's curve over rainfall hydrograph along with infiltration, we can also work out runoff component, because rainfall hydrograph will give information related to rain. Horton's curve will give information related to infiltration. So total rain that occur over a ground, total rain that go into ground, the difference will give the amount of water flow above the ground as runoff. The water flow above the ground is called runoff. So how much water flow above the ground as a runoff, that also we can estimate. So by superimposing Horton's curve over rainfall hydrograph, along with the infiltration, runoff also estimated. Runoff can also be estimated. Isn't it? So how we can estimate, let us see. So I've got rainfall hydrograph with me. Rainfall hydrograph is nothing but a plot between rainfall intensity versus time. Intensity of rainfall versus time. This is called hydrograph. So you got this is your, okay, What is this? This is your rainfall hydrograph. So like this rainfall hydrograph is given, different time intervals, different values are given here. So 0, T1, T2, T3, T4. What is this? Rainfall intensity versus time plot. This is intensity so and so mm per hour versus time in hours, or centimeter per hour or mm per hour, whatever it may be. Okay, this is called this I1, I2, I3. So over which what you need to do, you have to superimpose Horton's curve. This is Horton's curve, let us assume. This is your Horton's curve. So Horton's curve is superimposed over rainfall hydrograph. This is hydrograph. This one is Horton's curve. This one is Horton's curve. See now area under Horton's curve is what? Infiltration. Area under Horton's curve is this portion, yellow. This is green color hatch is infiltration. Then total area of hydrograph is rainfall. Rainfall minus infiltration is equal to runoff component. So their area of hydrograph above Horton's curve is called runoff. That blue color hash, or red color hash, otherwise blue color, I'll put blue color. Okay. So runoff is equal to rainfall minus infiltration. So because it is instant loss, before other losses occur in a catchment, the first loss catchment experience is infiltration. Because other losses to occur in a catchment, it takes time. But we are instantly calculating runoff component. Therefore, other losses you can neglect, ignore. If they are asked to consider, we consider. Otherwise, we ignore. So therefore, runoff R is equal to, it is rainfall P minus infiltration F or I, whatever it may be. Whichever symbol you can give, you can give. Infiltration normally we denote it by F. Infiltration. Okay. Infiltration F, okay, no problem, any symbol you can give. Okay, so rainfall P is equal to what? Area of hydrograph will give rainfall information. Area of hydrograph if you measure, you get rainfall information, right? Infiltration F is equal to area under Horton's curve. So 0 to T, it is FC plus FC naught, okay, area under Horton's curve. Therefore, runoff R is equal to, it is area of hydrograph above Horton's curve. Area of hydrograph above Horton's curve is called runoff. Above Horton's infiltration capacity curve. Technically, that is the definition of runoff. So where is that area of above Horton's curve? So this is the portion I am talking. So superimposed Horton's curve over rainfall hydrograph, and you got, this is your Horton's curve. So this hatched portion, this red color hash is there, no? This is called runoff component. Area of hydrograph above Horton's infiltration capacity curve is called runoff. Otherwise, I'll put this in black color. This is Horton's curve. Horton's curve is mentioned there in black color. Hydrograph is blue color. Red color component is runoff. That's all. Nothing will be there. Comfortably you can work out. Let us work out few numericals related to Horton's approach. Okay. This is GATE question asked in 2000. GATE 2000 question. Let us solve one question. Example number. How many questions are solved earlier? 2. Okay. 3. The question is given as like this. He has given like this, Ft is equal to Fc plus F naught he has given, but we took it as Fc naught. F naught minus Fc. We took it as Fc naught minus Fc, we took it as F naught minus Fc into e power minus k into t are given as F naught is equal to 7.62 centimeter per hour. Fc is equal to 1.34 centimeter per hour. And K is equal to 4.182 per hour. So K is known as infiltration rate constant it is. So for assumed continuous ponding, the cumulative infiltration at the end of 2 hours is, options given are 2.68 centimeter. Infiltration is asking at the end of 2 hours. Total infiltration. B 1.5 centimeter, C 1.34 centimeter, D 4.18 centimeter. Come on, work out. One try. So what is given to you? Actually we took it as Fct is equal to, it is Fc plus Fc naught minus Fc into e power minus kt. But he has given in the equation Ft is equal to, it is Fc plus F naught minus Fc into, both are same only. So in this equation what is given? Fc is given. Fc is given in the question as 1.34 centimeter per hour. And Fc naught, Fc both are same only. Fc naught and F naught both are same only, which is given as 7.762 centimeter per hour. And K value is given as 4.182 per hour. So therefore if you frame equation and write, so it is Fct is equal to Fc 1.34 plus Fc naught minus Fc 7.62 minus 1.34 into e power minus 4.182 into t. This is equation. Infiltration capacity equation for that catchment or for that soil. It is a soil property. Infiltration is a soil property. Soil to soil equations may change. Nature of equation is same, but values may change. So it is 6.28 into e power minus 4.182 into t. That is Fct equation. Okay? We got Fct equation. What is asking? Infiltration in 2 hours. So what to do? So cumulative infiltration means total infiltration. So total infiltration in 2 hours is equal to, so you have to integrate this equation between the limits 0 to 2. 0 to 2. What is that equation? This equation. 1.34 plus 6.28 into e power minus 4.182 t. This you have to integrate with respect to dt. Come on, do it. You will get total infiltration in 2 hours. Come on. If you integrate 1.34, what you will get? It is 1.34 into t. Integral dt is equal to t, 0 to 2. And if you integrate, this is in the form of m into e power minus nt, integral 0 to t dt. The solution for this is, it is m by, I will help you, okay? One time you have to learn integration. Integration is important for you. You can't escape. Because in this question there is no information regarding steady state and all. So without integration, of course you can verify and work out, but why unnecessarily? Let us integrate. So it is in the form of m into e power minus nt, integral 0 to t dt. Here m is equal to 6.28, n is equal to 4.182. So solution for this is minus m by n into e power minus nt, that's all. And substitute limits 0 to t. So now similarly work out here, it is 6.28 minus, no, minus will come here, minus 6.28 by 4.182 m by n into e power minus 4.182 t between the limits 0 to 2. If you integrate, you will get that answer. So 1.34 into 2 minus 6.28 by 4.182 into e power minus 4.182 into 2 minus e power lower limit and upper limit, both you have to subtract, into 0. Then simplify. So this becomes 0. E power minus 0 is, it is minus 1. Minus 1 into this one plus 1 this is. So it is 1.34 into 2 minus of minus become plus 6.28 by 4.182. So 1.34 into 2 plus 6.28 by 4.182. So it is 4.18 centimeter. That is the answer for this question. So options, verify what options are given to you. 4 is there, no, 4.18. So that is the right option. So this is how we need to work out the questions. Clear now? Let us try one more question. Still time is there, one more question, let us try. Okay? Simple question, let us take this is also asked in ESE exam. Infiltration rate after the storm has lasted for simple question. This much information is there here. For a long time shall be. And he has given options. Less than 0.2 centimeter per hour. B, 0.2 centimeter per hour. C, between 0.2 and 0.5 centimeter per hour. And D, 0.5 centimeter per hour. These are the options given. The vertical hydraulic conductivity means the point you need to remember is nothing but infiltration capacity. Vertical hydraulic conductivity also known as infiltration capacity, also known as vertical hydraulic conductivity. So indirectly he has given infiltration capacity. So infiltration capacity is given as 0.2 centimeter per hour. Okay, this is given in the question. Then rainfall of intensity, how much intensity rain is occurring? 0.5 centimeter per hour. Then what is asking? Right? Actual rate of infiltration is asking. He is asking the infiltration rate, means actual rate of infiltration. So since I is greater than FC, therefore FA is equal to FC only. That is the answer for this question. Since I is greater than FC, therefore FA is equal to FC. Therefore answer is 0.2 centimeter per hour. So this is the answer. B is the answer. That's all. Okay, so I'll stop here. Again, we'll continue our discussion with infiltration tomorrow. Tomorrow same time we'll meet once again, 2:30 to 4:30. Until then, goodbye and bye-bye. So before we conclude, so Unacademy is offering 23% discount. You can avail. Use code GATE ESE, flat 23% discount on all subscriptions. You can avail this. Grab last minute only. Limited period offer it is. Offer going to end very soon. So use it. So Unacademy conducting mock exams free of cost. Enroll. Mock exams, enroll. Unacademy conducting mock exams, enroll free of cost. Okay, bye. Tomorrow we'll meet again 2:30 to 4:30 and we'll try to complete infiltration by tomorrow, or if not, day after tomorrow. Okay then, bye bye, goodbye. We'll meet once again, same time, same place. Until